Use the compound interest formulas A equals P times 1 plus R over N to the NT power and A equals P times E to the RT power to solve the problem given. Round answers to the nearest cent. Find the accumulated value of an investment of $15,000 for 5 years at an interest rate of 4.5% if the money is A. Compounded semi-annually, B. Compounded quarterly, C. Compounded monthly, and D. Compounded continuously. First, we want to find the value when the account is compounded semi-annually. Now we're going to use this formula to find compounded semi-annually. This formula is only used for compounded continuously. So we'll use this first formula here, and we're going to identify the values for N, R, P, and T. N is the number of times that the amount is compounded a year, and our problem tells us that the value is compounded semi-annually, so that means it's compounded twice a year. So N equals 2. R is the interest rate, which is 4.5%, and we always write the percent as a decimal. So 4.5% is the same as 4.5 divided by 100, which is 0.045. Next, we want to find the value for P, and P is the principal or the amount that we're investing. So this will be $15,000. And then T is the number of years, which is 5. Now we're going to take all of these values and plug them into the formula to find A, which is the accumulated value. So here we plugged in the values for N, R, P, and T, and we have A equals 15,000 times 1 plus 0.045 divided by 2 raised to the 2 times 5 power. The first thing we want to do is divide 0.045 by 2. When we do that calculation, we get 0.0225. And then we're going to multiply the exponents together, and 2 times 5 is 10. Now we have A equals 15,000 times 1 plus 0.0225 raised to the 10th power. Next, we'll add 1 plus 0.0225 together, and we get 1.0225. Now we'll take that value and raise it to the 10th power. And we should get 1.249203426. Lastly, we'll multiply that value by 15,000, and we get an answer of 18,738.05139. Since this is a monetary value, we need to round to 2 decimal places, so our final answer is $18,738.05. And this is our answer to part A.